n equals to 1. Supersymmetric quantum mechanics in different aspects. Let me briefly remind you what we have done, and I would like to change notation just a bit. I'm sorry for inconvenience. We had a superspace with coordinates t, theta, theta bar. These were odd. We had operators of supersymmetry. And operators that were commuting with them. We had a superfield phi. And now I'd like to rename the coordinate. Sorry, not the coordinate. It's components that depends only on t and not on theta. It's better to call it x. I'm sorry. No bar here. We computed Q applied to phi I. It is clearly psi I plus theta bar Fi from these two terms. But also theta bar, I'm sorry, dt phi I plus the last term. So it is F. And the last term so when I apply this dt here, sorry, not on phi, on x. I'd like to make formulas cleaner. And there is the last term that I am getting out of this formula, and it is theta. So I act from the left. It is theta bar theta dt psi bar dt psi. I'm sorry. So let me make it properly. So when I differentiate, I always have this problem in differentiation. d over d theta gives psi and theta bar f. Then I have dt xi bar. Then there should be psi bar somewhere here. Okay. Okay. So from this formula, I conclude that Q applied to xi equals psi I. Q applied to psi bar I equals dt xi plus fi. And also I have term that Q applied to fi equals.
Wait, but this is assuming that the phi field is what? Is the eigenfunction of Q?
No, it's not the eigenfunction. It's just a function of t and theta.
But then Q applied to xi is theta bar dt of xi. Why do you equate these terms?
So let me try to explain how I am doing this. I am applying differential Q to the superfield, and I see what happens with components. So Q applied to phi I. You see, I just applied field Q to the field in the formula 1.
Yes.
And what I have seen? I have seen that as a result, I have the formula 2 if I have not done any mistake.
Okay.
So what does it mean? It means that components transform correspondingly. Xi goes to psi I. So probably it's better to put here tilde. Tilde says how components are transforming.
Like delta x. Delta x is.
Yes.
Yeah, some kind of variation of x. Maybe
Yes.
a small delta, because q is very confusing here.
Okay. Okay. I agree. Then I will write it like this. Delta Q. Okay?
Yes, this looks much more understandable.
Okay. And similarly, I have delta Q bar. Of psi I would be dt xi minus fi. So this minus comes from this ordering here. And also I have delta Q bar of fi, that is dt psi bar I. Okay. And having this, I have similar formulas for delta D, but people call it D in the similar way. So they differ just by the minus sign. And let me also write it down. So when first term is the same. I just like to write down schematically how it looks like. Plus, no, so it's this similarly, but no, I would like to write down here, not this. I would like to write here D of phi I. And here term is the same. And here I have a minus sign. And minus theta bar theta dt psi I. And similarly, I'll write down d bar of phi I. Minus theta plus theta fi and here plus or minus, I don't remember, but it's not that important. The reason I wrote it down here is that I would like to write down an action. And here I have a metric, Gij. depending on the field phi. And here I put d phi I, and here I put d bar phi j. It will be the first term. I am briefly reminding what was last time. Now, case 1. Gij is constant. In this particular case, we need to pick up two thetas. So we can try to see where we can pick them up. So unfortunately, I think the relative sign at one of the places, like here, is minus. But you see, it's kind of the mathematical, or maybe plus, minus. So how to get two thetas? We can either get one theta from d phi and another from d bar phi. And that will bring dtxi plus fi dtxj minus fj, and here we have gij. This would give gij dtxi dtxj minus gij fi of j. So it is one way. This is from terms in, how would I like to call it, 3. Linear in theta. However, I can pick term quadratic in theta. And this term quadratic in theta is derivative of psi. And this will bring structure like this. Well, I can add so-called superpotential. So these two terms would form so-called kinetic term. It is d2 theta, and here I take function w as a function of phi. So it would bring what? What it will bring? Looking at the formula 2, at the formula 1, I see that I can get two thetas by taking derivative of w with respect to phi. I will call it x. So phi is the superfield, and I will just call it x. I. And here I have fi term. But there is another option. Another option is to get terms with fermions psi. One theta from each fermion. And it would be so this would bring potential term. Altogether, I get now I'd like to remind you that what is this? This is the action. That field F has no time derivative in the action. So it could be eliminated by Gaussian integration. It appears here and here. The result is so instead of this, I have this term. Now we see that we have theory that is free theory for boson xi of t with potential GIG and theory of fermion. Interacting with boson by such term. Okay. Let me go to interpretation of such theory in functorial formalism. Formalism. First, about boson. I study functional integral over field X with the boundary condition. So this thing belongs to functions on X times functions of X. Second, now I consider fermion. For fermions, I have the first order system. Plus interaction. So when I have a first order system, should be treated like bosonic first order system. Reminder. So I'm not very careful about eyes here. What I'd like to see dot means time derivative. That here I fix boundary conditions on X. And here I have the same boundary conditions on X. No boundary conditions on P. So that's why. So I treat fermions in a similar fashion. So in this integral, I impose boundary condition only on psi. Psi is treated like X. Altogether, the functional integral is a function of x0 I psi 0 I xt I psi I t. So it belongs to the space of differential forms on X times the space of differential forms on X. Because functions of x0 and psi0 are differential forms. So I have an operator. Well, I need a language that would translate me fields in the operator. In functional integral, approach, we say that local observables are just local function of local fields. What does it mean? It means that we study integral, and here we have Lagrangian integral of e to the from 0 to t, and here we have Lagrangian fields dt, and here in the pre-exponent we put O of phi evaluated at some point t1 in this interval, and we interpret it as e to the t1 h operator O e to the t minus t1 h. Suppose t tends to 0. What are operators corresponding to local observables? So simplest case is xi is just multiplication by xi. It was easy. Now we computed before that momentum, bosonic momentum, Gij dt xj, this operator, equals d over d corresponds to d over d xi. Similarly, psi I is just multiplication by psi I, while psi I bar, being a momentum, corresponds to d over d psi j. being a momentum for psi. So we see it from the formula that I have not numbered, but this formula is here. So this is how it works in the bosonic case. And we actually have observed this not only from this bosonic integral, reminder, we observed it by studying so-called P and pi observables in instantonic approach. It is where we studied minus epsilon PV integral and we were taking derivative with respect to epsilon at epsilon equal to 0. So we studied this. So like for T1 greater than T2. So in one case trajectory was like this. In another case it was like this. So there was a epsilon jump. So if you don't remember this, you may take this as granted. Now, my goal is to show that operators announced, namely d plus dw and d star plus dw star are actually q and q bar. So what do I want to show? I want to show that d plus dw supercommutator or commutator with x is delta q esteem pointing me x d plus dw psi I is delta q psi I and d plus dw psi bar I is delta q bar psi bar I. So I have A, B, and C. A is easy. dw commutes with x, while dx I is psi I. Checked. Case B is also easy. It is 0 equals to 0. Let's have a look. At the transformation formulas. I forgot to write that delta Q on psi is 0. By the way, it's obvious from the formula because the Q squares to 0. However, there is an interesting piece. Interesting piece is C. Psi d over dx plus, plus psi I dw over dxi. Interestingly, anti-commute with this guy, with gi. I know how to write it. Ij bar d over d psi j. Here actually I need to put anti-commutator. And I have two terms. First term is g ij d over d xj. And there is a second term. And the second term is g ij d dw over d xj. Now, from delta q on psi I, we know that delta q on psi I equals dt phi, dt xi plus fi. Now we are coming to the culmination. This term is dt of xi. And after integration over f equals gij dw over dxj. So t is proven. Now, what about d star plus dw star? That is actually minus gij d over dxi d over d psi j plus gij dw over dxi d over d psi j. May be treated in the same way. I will still write it to bar. It is clear that q bar acting on xi is minus gij d over d psi j. So probably there is an overall minus sign somewhere here. So it is, okay, up to the minus, it is minus psi bar. So I'd like to write it like this, as expected. Similarly, interesting term is q bar applied to psi I contains two terms. And this is minus dt xi operator plus fi. So that's why I completed the proof that the quantum mechanical system constructed not only gives corresponding Hamiltonian, but also, finally, thus Q and Q bar are actually d plus dw actually correspond. Okay, so now we will have an 8 minutes break and then we will continue. So let me continue. I intentionally copied formula 3 here. And the reason for this is that now I'm going to consider case 2. Non-constant metric Gij. And I'd like to look at the new terms. What are new terms? We have Gij that was depending on phi, that was x plus theta psi plus theta bar psi bar plus theta bar f. For non-constant metric, it is possible to get sum of thetas from the dependence of metric on the superfield. In particular, we get the following term: dk Gij f k. And in this case, we need to take parts of d phi and d bar phi that do not depend on thetas. We may also take first derivative of j and get thetas from psi terms. So we will get terms like this. say psi k. And then it turns out that we need to take theta. So in this way we take theta, but then we also need to take theta bar term. So I took this derivative, and then I have a possibility. Where can I get? So in this way, I got the theta term. Okay? To get theta. So I already had theta. So I have psi bar I. But I also need to get theta bar term. And here I'll have a term like dt xi minus fi. And similar term. Where psi and psi bar are interchanged. And finally, I can get two thetas by second derivative of g. By extracting these pieces. Psi k, psi l, psi bar I, psi j. You see, I have a lot of pieces. I have a lot of new pieces. I should be able to interpret them. And now, and it is a good exercise that you will never do, but please believe me. That by excluding f, remember that we have term gij. Sorry, metric was small everywhere. Fi, fj, we get Riemann curvature psi I, psi j, psi bar k, psi bar l. How to see it? R symbolically is d gamma minus d gamma plus or minus, depending on convenience, gamma gamma. where gamma is one half g minus 1 dg plus dg minus dg. And there are indices here. So that's why R contains dg terms and also d2g terms. So d2g terms come when I differentiate here. dg terms are coming from commutator of Christoffel symbols and when I differentiate here. So one may check, it's kind of tedious computation, that everything sums up in the Riemann curvature. Now, what about dt x term? They stand in front of psi bar term. dtxi terms sum up into connection. Levi-Civita connection. So the total action looks as, in the curved case, plus I. Here, of course, we have D plus superpotential term. So this is how the model looks like. Now I want to show two interesting features of this model. I will introduce a new notion, new concept. It is called Witten index. I will do the following. I will consider a space of states of an abstract. Topological quantum mechanics. V. It is Z2 graded. Then I assume that H, that is QG, has a discrete spectrum. And I will study supertrace over V of e to the minus th. It is something that I associate. It is the value of the functor on a circle of length t. So supertrace means that it is ordinary trace. In here I have minus 1 to the parity operator. Then theorem. I of t does not depend on t. Proof. Let us take derivative of I with respect to t. It is trace minus 1 to the parity e to the minus th, and here I have qg plus gq. Now I want to move q around the trace. And I will use the fact that q minus 1 to the p parity so p is parity equals minus 1 to the power parity q, because q changes parity. So here I'm taking q through e to the minus th. It's okay. It commutes. Through the parity. It's minus q minus 1 parity, I'm considering this term, e to the minus th. And I'm keeping g here. And this is trace minus 1 parity e to the minus th. And here I have gq. So term number 1 cancel term number 2. So this equals minus term number 2. So totally I have 0. This allows to do the following important trick. Compare t going to infinity and t going to 0 in the functional integral. What happens when t goes to infinity? Then trace super trace. So I wrote it, yes, super trace. Equals to the super trace e to the minus th only on harmonic forms. That are kernel of H. Other differential forms disappear. And I would say functional integral in the model we study. So this is minus 1 to the power k, sum over k, and here we have dimension of the space of harmonic forms, but they equal to the dimension of the space of k's cohomology of operator D. And this is known as the Euler number. Now let us see what happens in the opposite case. When t is very small. Claim when t is very small, we localize to constant maps. So what do I mean by this? Consider xi as a function of t, and it is some constant mode x not 0 plus xn, and here I have exponential 2 pi I n over t. Then dx over dt is 2 pi I n over t xn exponential. So again, we have dx over dt squared that equals 4 pi squared over t squared xn squared. I would say proportional. And the total contribution of this integral goes like xn squared divided by t. So for t tending to 0, it is exponentially vanishing. Since it's an exponent. So similar things happen for fermions. And altogether, the functional integral so it may be shown reduces to the integral over the space of 0 modes. So if we have 0 modes, then from the action we have only Rij KL psi I 0 mode, psi j 0 mode, psi k bar 0 mode, psi 0 mode L bar. But this is Gauss-Bonnet formula for Euler number. And here we got functional integral proof. There are some details that I omitted, but I explained your idea. when one can prove many mathematical theorems using this idea. All index theory theorems. But I am not going to go into details here. I still have time to explain the following, to explain another consequence of n equals to 1 superquantum mechanics. First, it is clear that operator d plus dw equals d is conjugated to d. So cohomology of d plus dw on the compact X equal to cohomology of d. Then, at the same time, cohomology of d are isomorphic to harmonic form. Harmonic forms correspond to potential. Gij dw over dxy, dw over dxj. And if we look at this potential, okay, plus term linear from boson-fermion interaction. Consider rescaling. W going to lambda w, where lambda is going to infinity. In this case, we can ignore terms linear in W, and potential looks like so here we have manifold X, and here is potential. So these are critical points of W. So simple reasoning so we may evaluate space of harmonic form. It is its dimension is not greater than the number of critical points. Why? Each critical point has approximate ground state with zero energy. And these states may only be lifted due to so-called tunneling effect. So roughly speaking, we have oscillators with a big wall between them. So tunneling can only deduce the number of harmonic forms. That equals to dimension of homology. So we get a mathematical statement. Number of critical points of the function W is greater or equal sum over k dimension HD k. And here we are coming to again to the framework of Morse theory. That I'll explain next time.